All right, let's go ahead and talk about this one problem that's been requested. So here in this video, I'm going to go ahead and review our order of operations and a little bit about how to add, multiply, and subtract fractions. All right, so here I already have a problem on the screen. 1/3 minus 7 over 6 times 9 over 14 plus 2/3 squared. So we have a lot going on here. So if I want to tackle on this problem, we need to talk about order of operations. In other words, we need to talk about, do I do multiplication first? Do I do addition first, subtraction, exponents? What's going on with that? So remember that we have this acronym called PEMDAS. You may have heard it from many other different ways. Please excuse my dear Aunt Sally, something like that. But let's break down and recall, what does PEMDAS stand for generally? So recall that whenever we talk about PEMDAS, here I'm going to move this over, the P stands for parentheses, and some books also include brackets. They're one and the same, parentheses and or brackets. So that's my P. E stands for exponents. These are the powers, squared, cubed, stuff like that. The next pair that I want to talk about is multiplication and division. Notice here that I put them in the same sort of row, and I put multiplication and division. It's not multiplication then division. We don't do multiplication first always and then division. These are one and the same. We're keeping them on the same level, in other words. And then I have the next pair being AS, addition and subtraction. Same thing as before. Note that I did not say addition then subtraction. I said addition and subtraction. Big caps and. All right, so this is our general order of operations that I want to go ahead and discuss. So using this order of operations, we're going to go ahead and look at this problem I have on the left. So let's go down our list. We're going to start off with the first layer, parentheses. Do I see any parentheses or brackets in this problem? Well, if I look at this problem here, you're probably noticing right away, I have a set of parentheses here around 2/3. So usually in the parentheses, that means whatever's inside the parentheses, I'm going to deal with that first and try to clean it up. Fortunately for us here, whatever's inside my parentheses, 2/3, that's already pretty much cleaned up. There's nothing we really had to do with our parentheses. So in other words, we're pretty much done with the parentheses. There's nothing for us to do. It's already cleaned up all the way as much as possible within the parentheses. Now we're going to go on and move on to the next part, E for exponents. So looking at this problem on the left, do you see any exponents, any powers? Well, again, looking at this problem, you're probably noticing the power right away. So in this case, the power is this squared here. We have this 2 here. This is a power of 2. To be more exact, I'm having this 2/3 to the second power, such as what I have highlighted here. So for E and exponents, I'm going to apply these powers as much as I can. In other words, what I have here highlighted, I'm going to go ahead and square 2/3 and try to clean that up. So how do I square 2/3? So I just want to remind y'all, how do I deal with a fraction being taken to an exponent? So in other words, how do I square a fraction? Well, one way that we can do this is that one great thing about fractions is that if I take it to a power, that's the same thing as saying, let's take the top part, the numerator, to that same power, and then the bottom, the denominator, to that same power as well. In other words, 2/3 squared is the exact same value as 2 squared divided by 3 squared. Again, it looks like I just put 2 squared, 3 squared, and that's exactly what I did actually. And then we can deal with this. How do I think of 2 squared? Well, remember 2 squared, that's the same thing as 2 times 2. And 3 squared is the same thing as 3 times 3. That's exactly what it means to square something. Multiply it by itself 2 times. So notice here on the left, I haven't touched anything there. I'm just working with what I've highlighted and changing that part. All right, so let's clean this up. 2 times 2, I get 4. What's 3 times 3? I get 9. So 2/3 squared, what I have highlighted here is the same thing as 4 over 9. So now I'm left with this bottom row here. Do I have any other exponents or powers to work with? Well, looking at this, there's no more powers that stand out for us. That tells me, yep, we're done with the exponents. Now we can continue down to the next tier in our list. So looking at this problem, I'm going to go ahead and clear the screen a little bit. Let me go ahead and move this bottom row up, just so that I have enough room on the screen. So my third layer is multiplication and division. So now looking at this problem again, do you see any multiplication or division? So looking at this, again, we can see this pretty quickly. I have a multiplication, this little dot here, that means times in the middle. So that means the next thing I should focus on is multiplying these two fractions together. So again, I'm working with the multiplication. I don't have to worry about division here because I don't see any division outside of the fractions. So how do I clean this up? Let's recall, how do we multiply our fractions? So I'm going to go ahead and show you one way that we could simplify this fraction. I do also want to point out that there's other ways that you might be familiar with or ways that you prefer to simplify a fraction. The way I'm going to show you is just one way to clean up the fraction. And because this gets a little bit involved, what I'm going to have here, I have this little curly brace here. I'm going to focus on what I've highlighted here. 7 over 6 times 9 over 14. All right, so working on this. Well, whenever I want to multiply two fractions, one way I can think of this is that I'm just multiplying straight across. In other words, 7 over 6 times 9 over 14. That's the same thing as saying 7 times 9 divided by 6 times 14. So this is just what it means exactly to multiply a fraction. I can multiply them straight across. All right, so I could multiply these straight across, but I'm actually going to do a little bit of a trick here to make my work a little bit easier. So at first it's going to look a little bit weird, but I'm actually going to rearrange this. Instead of saying 7 times 9 over 6 times 14, I'm going to write this as 7 over 14 times 9 over 6. So I haven't done anything illegal. I'm definitely allowed to do this. Primarily because here it's still 7 times 9. And down here at 14 times 6, you might be wondering, well, before it was 6 times 14. Remember that whenever I do multiplication, I can swap them as needed. 6 times 14, that's the same thing as 14 times 6. So what I have here is still the exact same value. I just wrote it in a little bit of a different way. All right, so why did I do this? Well, let's look at the left part. 7 times 14. Well, if I look at 7 over 14, some of you might be thinking, oh, this does clean up. Or if you're not seeing it immediately, I might say, how many times does 7 go into 7? Well, 7 goes into 7 one time. How many times does 7 go into 14? 2 times. So 7 over 14, we can actually reduce that and say that that's 1 divided by 2. And I'm going to do a similar trick here on the right. 9 and 6. Is there something in common between these two numbers? Well, as it turns out, I can divide both of these by 3. If I do that, how many times does 3 go into 9? Well, 3 goes into 9 3 times. Again, because we know 3 times 3 gives us 9. What about 6? How many times does 3 go into 6? Well, 3 goes into 6 2 times. Again, or we can also say we know this because 3 times 2, we get 6. So this other part of my fraction becomes 3/2. And you can see here, now I can multiply this straight across and get a pretty clean number. If I multiply straight across, what's 1 times 3? Well, I get 3. What's 2 times 2? I get 4. So this entire highlighted portion here can be reduced down and simplified into a 3 over 4, like what I have here. So now I have 1/3 minus 3/4 plus 4/9. All right, so we've done our multiplication that we saw initially. Now looking at this, is there any other multiplication left or division besides being a fraction? So I'm going to go ahead and clear up the screen once again. Let's move this over. Again, emphasizing that this 3/4 came from multiplying these two fractions. Well, if I look at this right here, there's no more multiplication or division that we have to be worried about right now. So I'm going to go ahead and claim that the M and D part of my order of operations is complete. So now my focus is addition and subtraction. Again, it is not addition then subtraction. We don't do addition first and then subtraction. We do from left to right addition and subtraction. So here I only have addition and subtraction left. So I had to clean up all of these fractions some type of way. So again, I'm going to show you one way to do this. There may be other ways that you like a little bit better, but this is one way that I like to introduce it. So since in this step we like going left to right, I'm going to focus on these first two, the first two on the left. In other words, I'm going to focus on 1/3 minus 3/4. Can I go ahead and clean that up? I'm not abandoning this 4/9. I'm just putting it aside for now because that's on the far right. All right, so 1/3 minus 3/4. How can I possibly clean this up? Well, if I want to focus on this, again, there's a lot of different ways. The method I'm going to use for this video, you might have heard it called the butterfly method or something like that, or crisscross multiplication. One quick way that I can do this without having to necessarily get a common denominator is I'm going to do some crisscross multiplication. And I'm going to show you how I do that. So I'm going to do my first diagonal. I have 1, and I'm going to say 1 times 4. What's 1 times 4? Well, I get 4, right? What was my symbol in the middle? It was a minus. And now I do it in the other diagonal. What's 3 times 3? I get 9. So I get 4 minus 9. That's my crisscross here. And then to finish up here, I'm going to multiply the bottom. 3 times 4. And that's going to give me 12. So by writing down all of these numbers, I can go ahead and clean up 1/3 minus 3/4. And it's going to give me 4 minus 9. That's what I had on the top. Over 12. And then we just went ahead and this is another way that you can say that we get a common denominator without really using that term. We still are doing it, it's that I didn't explicitly state it that way. All right, so 4 minus 9. What's 4 minus 9? Well, 4 minus 9, we get negative 5 over 12. So again, this highlighted part, what I have above these curly braces, that's equivalent to negative 5 divided by 12. All right, and I haven't abandoned this 4/9. I can just now rewrite this as negative 5/12 plus 4/9. All right, so I have that here. And now I'm going to basically do the exact same process. Again, we've cleaned this up more, and I can still do addition here. So once again, I'm going to move this over so that I have some space. And I'm going to treat it the exact same way. In fact, let me go ahead and clear up a little bit more space. I have two fractions that I want to add or subtract. I'm going to do my little crisscross butterfly method. So my first diagonal from the top left to the bottom right. Negative 5 times 9. I get, well, negative 45. What's my symbol in the middle? It was a plus. What's my other diagonal? 12 times 4. I get 48. And then I do my bottom denominators. What's 9 times 12? Well, I get 108. So if I want to clean up these fractions, I get negative 45 plus 48 over 108. And now I'm going to clean up the top. What's negative 45 plus 48? I get 3. So 3 divided by 108. That looks like a really nice number from where we started. But as it turns out, I could clean this up a little bit more. It doesn't always happen this way. Mainly because 3 goes into 108 perfectly. So I'm going to use this trick. How many times does 3 go into 3? One time. How many times does 3 go into 108? As it turns out, it's actually 36. And I can also verify this by saying 108 is the same thing as 3 times 36. All right, so reducing this and simplifying it, I get 1 divided by 36. And then looking at this, there's no more addition and subtraction. I've gone through all of my order of operations, so I'm done with my problem. All that work, I get 1 divided by 36. And so we're done. That's our final problem.